Hi, I'm Lee Teschler with Design World Magazine. I'm here with Martin Lass from Infineon. And Infineon has a kind of interesting single chip time of flight solution here that Martin's going to tell us about. Martin, it's quite an interesting display. Can you kind of take us through what's going on here?
Yeah, actually we have time of flight single chip imager. Actually, time of flight is a technology to sense 3D, your environment in 3D. And we do this with a single chip. So you need always infrared illumination to send it out. It's reflected by the scenery and then compared with the transmitted light. And out of this information, you gather the distance and also the amplitude picture in every single pixel.
I see. The infrared source, that's separate from the chip though, correct?
Yes, it's you can use an LED or typically for consumer applications we are using a VCSEL laser because it's much more efficient and so you save power.
I see. And of course you're generating an image, so you've got an image sensor there.
Yeah.
How do you coordinate that with the time of flight coming from the light source?
So actually the imager itself is doing the modulation. So just with the processor you can set the image sequence you want to do. You can set the frame rates, exposure time and everything. And then this is coordinated by the imager and controlling the light, the illumination. Yeah.
I see. The demonstration you have here is actually uses a cell phone.
Yes.
That's how small this thing is. Can you talk us through what's going on here?
Yeah, so actually we can show you later. It's a nice small depth camera which you can integrate in a cell phone. It's like in the project from Google Tango. We are a partner in this program, and this is targeting really to give mobile devices human scale understanding of the environment. And the depth information is one of the key parameters you need for these applications.
Interesting.
Yeah.
And this isn't a laboratory curiosity, this is a production chip, correct?
Yeah, so we have in several devices. So the first imager is already available. We have a next generation with micro lenses on top where we improved the sensitivity by the factor of 2. And this one is available in Q1 2016. And a smaller device with lower resolution targeting these consumer devices is coming in the second half of this year.
Okay. Let's go through the demonstration here.
Yeah, so actually what you see here, it's a available cell phone. And here on the back, we have just equipped it with our demo camera, the Cambot Pico Flex. It's done by our cooperation partner, development partner, PMD Technologies. So here you see the lens with our imager behind, and here it's the illumination. So, and we are running actually also the calculation of the depth map on this device. And we have a viewer of our solution. So, when I activate it, you actually can see here the whole scenery in 3D point cloud. You can turn that around, and so you see that the scenery is really in 3D information. So you can look from top or turn it a little bit around. So if I make it smaller, so you can gather all this information. This device is now optimized for 4-meter range with a depth accuracy of around less than 1% of the range. And by that we are using less than 300 milliwatt power consumption, what is at least a requirement for the Google Tango project. Another application you can think of using this 3D data is of course virtual reality, where you need data for hand tracking to act with your hands in the virtual world, or if you look down on you having the glasses in front, you can see your feet and everything, and that could be also done by such technology.
Interesting technology, Martin. Thank you.
Yeah, you're welcome.